Thank you, Greg, and thank you for the last two very inspirational presentations. This old white guy learned something today. Now, seriously, it's quite amazing when you get in your little niche to be pulled out of that and to learn something new. If ever I become too old to learn, then I need to go away. So I ain't going anywhere right now, though. So I want to talk to you about this International Lunar Resource Prospecting Campaign. And I've highlighted the international aspects of this with the folks as part of this team that are in orange. And I'll give you the conclusion right now. All we are doing is coordinating existing, well, 8 existing and 1 hopefully still existing mission to go to the moon and collect data about polar volatiles. That's the beginning. We ran 2 LSSW workshops about how do you define an international lunar resource prospecting campaign, and maybe more importantly, how do you then implement it? And one of the things that came out of that, well, this needs to be coordinated by a non-governmental organization. So I went and looked up what that meant. All right. And where the heck are we going to find a non-governmental organization to coordinate it? Because you can't have NASA do it because, well, as we heard, it's very difficult for NASA to do prospecting, but then it becomes a political thing because that's United States. So while I was exercising one day, I just had the thought, well, why doesn't the community do it? So fast forward to Space Resources Roundtable at the beginning of June, and in 22 hours, we had lawyers involved drafting an organizational plan for this International Lunar Resource Prospecting Consortium. We should have that draft finished by the end of this month. But why do we need that? What's the motivation? Well, the motivation for me comes from the Artemis architecture segments. And you can see there that the foundational exploration and sustained lunar evolution do call out in situ resource utilization and locating resources, and then mapping resource reserves and utilizing ISRU in those 2 there. And then the recent architecture document that came out, and I read a lot of pages. It's a riveting read, but it is incredibly informative. And we look at page 22, to minimize the risk to the Artemis campaign and ISRU product customers, NASA and its partners must plan a transition of Earth-delivered to ISRU-derived products, along with adequate resource mapping and demonstration of the ISRU processes and product quality. You go to page 145, and you get the shift from reconnaissance, initial resource assessment and sampling to resource reserve estimation and acquisition and processing occurs in this segment, which is foundational evolution. So this is something, how is this going to happen? Because I asked the question, and doing prospecting at NASA is difficult. So how are we going to do this? And this is what part of this consortium campaign is hopefully going to fill a niche, and we will see how it goes along. But let's get back down to some geologic definitions. This is the real, exciting stuff. We have to define what is a resource. Concentration of natural materials in and on the crust such that economic extraction is feasible. Well, what's a reserve? It's a portion of that resource from which a usable mineral or energy commodity can be economically and legally extracted. And there's the USGS, the font of all resource reserve knowledge, as we all know. And I put this little diagram up here, and I want you to focus on the axes here, because we've got increasing degree of certainty of existence heading towards the origin here. And then we've got increasing feasibility of economic recovery. Well, we can't change that right now because there's no demand. for lunar resources. So there's no economic aspect to it. But what we can do is to increase the degree of certainty of existence of these lunar resources. And it's a campaign. It's not a mission. It's a campaign of missions. And you can hear the dollar signs going crazy because these missions, they cost money. We've heard all about Viper. That's one mission. That's one rover. Well, we need a fleet of rovers. No one nation can do this alone, hence the International Lunar Resource Prospecting Campaign. But we need to increase the degree of certainty of existence for lunar resources, especially polar volatiles, because that seems to be, if you like, the almost low-hanging fruit to go after because of the implications of water, finding water for life support consumables, and maybe eventually rocket fuel. But everybody's stampeding to rocket fuel right now. And we know we got our one point of ground truth with Cabeus, and it's not pure water ice. It's dirty. So we're going to have to refine it if we want to get rocket fuel out of it. That's going to require technology development. That's going to require expensive tech demos on the surface of the moon. And we are not going to go from finding lunar water ice to rocket fuel in a few years. This is a process. So what do we need the water for? And think about those use cases. I'm not going to tell you, but I want you to think about what will we use water for on the moon apart from rocket fuel? Because those are the business cases. Rocket fuel has been the business case. That's the driver right now when you look at the business cases that have been done. But for the moon, initial orbital results require more granular surface data. And I take this from Carlos Espegel's paper. There's the DOI down there. And this is taking terrestrial standards, but converting them to lunar or reserve standards. And I've highlighted this feasible resources test line. And in order to get potential interest in creating demand, we need to get above that feasible resources test line to the probable resources reserves and then the proved resources and reserves. That's where we need to be. Now, there was another paper given by Ruby Patterson and Hannon O'Brien at the Space Resources Roundtable, and they put this plot together. So what do we see with the Prime 1, Prospect, Viper, and Lupex? We're getting close to that feasible resources test line. It's going to get us close, but it's not enough. More needs to be done, and that is the message that they gave, is more needs to be done. And how do we do that? So earlier this year, this paper came out in Acta Astronautica, and it's the measurements. What do we need? That table comes from the results of the first Lunar Surface Science workshop on resource prospecting at the moon. We need to look at required fidelity of data in order that critical business cases can be put together if we are to create a commercial aspect to this, and documentation, both NASA and non-NASA. Lunar resources will be the underpinnings of a vibrant cislunar economy. And without these data, these prospecting data, that is all, we're in dreamland. So this has to be done, and it's very important that it gets done. But the accuracy of those measurements, the coordination between surface missions, so we get comparable data sets from different permanently shadowed regions of polar volatiles, or different regions of higher concentrations of rare earth elements. These are the things that we need, coordination. Viper could be the benchmark, but it needs to be flown in order to be that benchmark. And many of these new data types would need to be taken via surface mobile assets in order to get the granularity that we need for those data. Now, if we do look at the work that's been done, and Harley Brown's work and co-authors 2022 ranked the PSRs in likelihood of containing water ice. And the 10 most promising sites would cover an area of between 5,500 and 6,500 square kilometers. That's a lot of real estate to cover, and one rover is not going to do it. So the thought from the consortium was, why do we need to go into the big PSRs right away? Why don't we look at some smaller ones? And so what you see highlighted in blue here are the ones that we want to target from orbit and then potentially with surface assets as we move along. But we need to get the orbital data and integrate those data sets so that we can make informed decisions of where to send the very expensive surface assets. And you can see I've highlighted Shackleton Crater there, but we've got to conduct sensitivity analysis on the data we get back from these missions because we need to know those uncertainties. So you see here, and I've included the Prospect, Viper, Prime 1, and the Lupex landing sites, and they don't really go anywhere near our sites of interest, but they're important for ground truthing orbital data. And the more surface data we get, the more we can reprocess our orbital data to make better predictive sense of what we have. And you could see I've sort of described those in terms of 6 different regions of smaller PSRs. And if we then look at an overlaid map of lunar prospector neutrons and Schweili's surface, indications of water ice. And again, I know ShadowCam says they don't see that increased reflectivity. We really need to ground truth that. But what you see then is that we've got these smaller PSRs actually sit in pretty much a neutron suppression zone. Now that's 40,000 kilometers per pixel data we're looking at there, so it needs to be ground truth. But within those, and you can see here, this line, here's Shackleton Crater for comparison between the two. This line up here represents that line right there. Smaller PSRs are likely to be more accessible, and ShadowCam has pictures of a lot of these targets. So again, wrong one. Okay, well, that's moving. All right. There we go. So what we've done is we have coordinates for the center of these different PSRs that we've gone after, and a proposal is about ready to go to some orbital missions that are either at the moon or going to the moon to ask for, if you've already collected the data, can you share the data sets with us? And then we want to integrate those data sets so that we can then start to pinpoint hot prospects. Now that's the important point of this that I want to get out. So a campaign is a series of missions. It's going to be expensive. But there's been a 21st century renaissance at the moon. And these are all the missions that have gone to the moon. And there have been 5 lander failures. Landing on the moon is difficult. There's been 5 lander failures in this century, and usually from non-traditional players. But you looked at the Lunar 25, the Russian Lunar 25 mission. That failed to land. It was a litho-braked lander, and that's not good. But it's difficult. We get that, but we're getting closer, and you can see down there with the Intuitive Machines IM-1, that landed well. And we've got sample returns from Chang'e 5 and 6. We heard about that, a little bit about those earlier in the meeting. So if we also look at what's planned between now and the end of this decade, there are 30 robotic lunar missions are funded and under development, and 16 more have been proposed but aren't yet funded. There are missions going to the moon. We need to coordinate them to get the data that we need in order to get the prospecting data and the prospectivity maps so we can get to the surface and start becoming predictive of where to go to actually find reserves of water ice rather than, yeah, there could be water ice there. So that's the whole point. Coordinate existing missions rather than starting new mission lines. So we've talked with LRO, the Korean Pathfinder Lunar Orbiter, Chandrayaan-2, and Lunar Trailblazer. And surface missions with landers and rovers, and I've kept Viper in there. I'm forever the optimistic person. But Prime 1 is a tech demo, but it will give us important data. What if Prime 1 does find buried water ice on that ridge? It'll surprise everybody, but the moon does that. You think you're not going to find something and you find what you did not expect. So we'll have to go there and ground truth it. There's the Lunar rover mission from Canada and Lupex and the Prospect package that will also fly an Eclipse lander from ESA. All right, let's, what about other relevant missions? In the lead chair statement, we had Chang'e 7 and 8 are going to the South Pole to Prospect. Can they be part of this? Sure. We only want their data. So, and then Russia has got Lunar 26 and 27 also polar missions. So I'm not going to go through this in much detail, but KPLO, Chandrayaan-2, and Lunar Trailblazer are shrinking the pixel size so that we can get multiple pixels even within a smaller PSR. Critical. We start integrating these different data sets, we can then start to point to where we go to the surface. And we got to conduct sensitivity analyses on the derived products. So there are 3 features for a legal framework that we're following. Organize the campaign as an international joint venture. We are then compliant with the Outer Space Treaty. Or adopt a multi-purpose data policy. Exactly, we should do that. Develop shared standards. There's a lot of work involved. And I'm just going to put this up there because this is the organizational structure that we've come up with, and it's a work in progress, and I don't expect you to read it, but this is starting to become real, going from the International Lunar Resource Prospecting Campaign to the International Lunar Resource Prospecting Consortium, and there's more to come.